Hey everyone, you're with Tesla Tom. Thanks so much for joining us on Ludicrous Feed today. Well, today's kind of an overcast day with some bursts of sunshine through the clouds here in Sydney. Have a look at this video here I just took recently of the PowerWall2 during those bursts of sunshine. So at 7.1 production from my panels, it's charging the PowerWall2 at 5 kilowatts and some of it's going to the house, and a lot of it is being supplied as a feed-in tariff back to the grid as well. So that's kind of my everybody wins situation where you know, the house, the PowerWall2 and the grid is winning as well from solar energy. Now I took this other screenshot at pretty much the same time here. So the shot on the left is a point in time when the panels, both sets of panels, were producing 6.8 kilowatts. 5 kilowatt is being charged to the PowerWall2. That's maximum charging for PowerWall2. 1.4 kilowatt is going to the home, and the rest is going to the grid as a feed-in tariff. The picture on the right is my old inverter, my 3.6 kilowatt inverter with 3 kilowatt panels, and it's supplying the home at 2.5 kilowatts. Now, it got me thinking, because if you sort of by deduction take away 6.8 minus 2.5, that's only 4.3 kilowatts that my new 5.4 kilowatt array is producing. That's understandable because one, inverter efficiency is only 95%, and also my panels, as you might know from my previous videos, are orientated at northwest and northeast, so it's not always at optimum direction, so you're never going to get that full 5.4 kilowatts. So, you know, at 4.3 kilowatts, I'm thinking, how can it possibly charge the PowerWall2 at 5 kilowatt? When, from this diagram here, I'm going to show you on my whiteboard, the A phase of my 3-phase home is my new solar array, charging the PowerWall2 and also charging the home at A phase, and also supplying the grid. And the B phase is my old panels, 3 kilowatts, powering the home and also supplying the grid, and C phase all by itself. So if the PowerWall2 is charging only at maximum 4.3 from A phase, where is the 0.7 coming from? We know that B phase, my old panels, can't cross phases. It can't directly supply the PowerWall2 because the PowerWall2 is single phase stuck on A phase. We know that physically and electrically the B phase panels can only supply the grid all at once or power the home. So I think this is where the 3-phase net meter comes into play. So even if on A phase, the maximum it can charge the PowerWall2 at that time is 4.3 kilowatts, where is the 0.7 coming from? So it must be coming from the grid, right? It must be coming from the grid, 4.3 plus 0.7 to make up 5 kilowatts, which means that through the net metering process, the B phase is supplying the grid, you know, whatever it is, and then the grid is taking back 0.7, and it's not charging me for it because it's going to take off that take off from the balance from the B phase, and the net meter will go, okay, there's actually nothing happening here, nothing to see, and I don't get billed for that energy I'm taking from the grid. But that's how you get the 5 kilowatt in a 3-phase system with 2 different sets of panels operating at once. I think that's pretty cool. It means that I'm never going to sort of quote-unquote waste energy by sending it off the grid when the PowerWall2 is not charging at 5 kilowatts, which is the maximum charging rate. Like, you're never going to see a situation where like the PowerWall2 might be charging at say 4 kilowatts from my new panels, but the grid is getting exported at like, you know, 3 kilowatts. That's not going to happen, I'm pretty sure. You're always going to get a top up of 5 kilowatts with the excess being seen as a feed-in, which is good because you kind of want to charge the PowerWall2 as quickly as possible so you can use the energy at night time when the sun goes down. I think that's the best use of a battery. Alright guys, I hope that makes sense. That's how you get 2 different sets of panels with a battery on the A phase or on single phase and a 3-phase net meter. You don't sort of waste the energy going back to the grid. You fill the battery as much as possible to maximum charging rate, and the net meter does its thing. Alright guys, thanks for watching. Thanks for supporting Ludicrous Feed. Don't forget to like, comment and subscribe. Thanks for watching, and as always, happy charging.
Thanks for watching, and thanks for being part of the energy revolution. If you haven't done so already, be sure to hit subscribe to stay up to date with our latest videos. Happy charging!